drop until we start doing this. Increase, 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 increase. Now we increase pressure in the engine. That's when we start flowing back out the tube. Okay, so manifold pressure is this, RPM per here. If you got it, advanced power, increase RPM, then increase manifold pressure. Decrease power, you're going to decrease manifold pressure first, and then bring these back. What you're trying to avoid is you don't want this to be low and RPMs to be high. You're trying to avoid high RPMs with low manifold pressure. Okay? Low RPMs, high pressure. You don't want that. In other words, you don't want to retard the power that up and start bringing this back. That's going to cause this to drop and this is high. You don't want that. You don't want high manifold pressure with low RPM. But now the rotation of the prop is slowing down. Prop control first. There you go. Nope, the other way. Push it all the way and push the button all the way in. There you go. Now that. Now decrease power. Come in, decrease power. Good. And then reverse it head back. That's the way. 28 degrees. Yep. Up, back up. You gotta go front. There you go. Correct. Exactly. Got it? Okay, so what that's doing here in the governor, that control, is controlling the oil pressure going to and from this, the hub. Inside here, there's also a piston, a very small piston. And it's sliding back and forth and mechanically altering the blade angle here. So when you change the prop lever, you're controlling this, which is delivering more or less oil to this area, and it's just engine oil. And that's forcing the blade to change angle. When you get into commercial plate theory, you get much more in-depth in this. But for now, it's just like you need to understand how to add power and reduce power on a constant-speed prop. And what are the advantages of the constant-speed prop? They allow the pilot to do what?
Maximum cruise performance.
What does it do? Constant-speed prop? Because you had this question yesterday. I don't forget. What does it allow the pilot to do?
No, it's some with rotation.
To get the best
Take off power?
No. What does a constant speed prop allow the pilot to do?
When you set the power, it will adjust to
It allows the pilot to do what? What can the pilot do? Different from that engine over there.
Oh, you can adjust blade angle?
Just the blade angle.
Oh, that was it? The best performance.
I'm thinking.
It allows the pilot to adjust the blade angle. Constant speed prop. What's wrong, Sam? What's that expression for?
I thought that was automatic, you know. I thought it was a more complex question than that.
Yeah, me too. I'm thinking.
So, a constant speed prop allows the pilot to adjust the blade angle, right? Once you've adjusted the blade angle to give you the RPM you want, then if you pitch forward or pitch back, the governor, what does the governor do for a state?
Regulate.
Okay, regulates, right? That's what this is going to do. This is going to regulate this blade angle and constantly change it to keep giving you the RPM that you set. You wanted 2,400
Oh, I
RPM
thought you would
for
have
your
to
flight.
keep changing it as you pitch up and down.
So when you get in the air, you get a cruise, you are going to set the power you want.
Uh-huh.
So we're going to reduce power. What's the first thing we're going to do? We're going to grab which lever to reduce the power?
Throttle?
Throttle. We start bringing the throttle back to a manifold pressure that we like. And then we're going to grab the propeller control and we're going to twist it back to give us the RPM we want. So let's say we were at 2,600 RPM for the climb and you want to lower the RPM to 2,400 RPM. That's going to make the engine, the noise less. You're going to burn less fuel because the revolutions are less. It's like in your car. If you go down the interstate and your RPMs are way up over here, are you burning more gas?
Yes.
Yes. Until the gear shifts and then boom, it drops down a little bit, right? And then you're burning less gas. Same thing here. Your RPMs are going to go from 2,600 to 24. So you're twisting back. So you are doing what now with the blade angle? Are you changing it?
Yeah.
Yes. You're changing it through the governor. You're forcing the governor.
The governor's changing it.
Remember when I moved that lever?
Uh-huh.
What was it moving? The blue knob. It was moving this right here, right?
Yes.
Which is the governor. So you are adjusting to force this blade angle to change. You're slowing it down. Then you've set it. Set it and
Forget it.
forget it. Okay. So now we're at 2,400 RPM. We're flying along. And let's say we pitch down. What would that airplane do? The RPM.
It will raise up.
Raise up.
Increase. Pitch up.
Decrease.
Okay, not this one. This one, when it senses that the RPM, that the blade is going to start increasing, the governor senses that. It has inside the little flyweights, right? And they start increasing. There's a pilot valve in there. It adjusts the oil pressure and it says, oh no, blades, start to change because I want you to change to keep 2,400 RPM. And they will constantly adjust the blade angle to give you 2,400 RPM, hence the term constant speed prop. The speed we want, 2,400 RPM. It's going to keep doing that. It's going to keep modulating the blade angle to keep giving you 2,400 RPM, all by itself.
But that one doesn't
Until you want to change the blade angle. Then what prop lever?
prop lever.
Which lever will you grab?
The prop.
The prop lever. So let's say you want to increase the power now. You're like 2,400. I want to get there faster. Let's go to rental power. I want 2,600 RPM. So which you're going to grab first?
Blue lever.
The prop lever. You're going to increase it. Now what are you doing? You're forcing the governor to change the blade angle to give you 2,600 RPM. And then from that point on, it's going to keep modulating the blade angle. If you change pitch, it's going to keep changing the blade to give you 2,600 RPM.
So that one doesn't have a governor?
It does.
It does?
Oh, no, this one does.
No,
That
that one
doesn't.
doesn't have a governor.
No, it's fixed.
Fixed propeller.
So it doesn't have a governor.
The blade is fixed. This one, constant speed. It has a variable pitch prop. It's got the piston inside, oil pressure. It's got the governor here.
Yeah.
Is it making a little bit more sense on how it works?
Yeah.
The Cirrus has a governor, but the difference with the Cirrus is they made it so simple that mechanically, when you bring the throttle up, it goes through the governor and changes, a desired RPM. You can't vary the blade angle other than just changing the throttle. On this one, you can't. Now, this one's even more sophisticated because this is called a full feathering propeller. So come over here. Somebody put your button.
Oh, this is a jet.
So on this propeller blade, look at the angle here. So this airplane's flying this way. This propeller is what's called feathered. It is feathered, meaning that if this engine failed in flight, we don't want the prop to windmill around. We don't want it to keep doing this because it adds drag. So we want it to seek the path of least resistance because now since the engine's not rotating, where's the relative wind if the airplane's flying this way?
It's back towards this
Going
way.
back this way. So the least resistance would be to change the blade angle from this, which like that, look at that blade. We don't want it flat, going through the air like this. We want it like this, the least amount of resistance. This is called feather. So that prop over there, the Seminole, has the capability of twisting the blade from that, see that one right there, the fixed one, from a very flat blade angle, to feather, which will make this prop not rotate around and decreases drag. The Cirrus doesn't have that capability because it only has one engine. It doesn't need to have a feathering prop. So there are different types of constant speed props. There are full feathering props and those type there. That's traditional. Now this is a turbo prop also. It's a little different. The engine is different.
With a full feathering, could you feather it so you can change the pitch to even like make you go backwards?
Different engine out.
It would be like this. It would go like that. Not once you're feather, that's it.
Not feathered. I mean, can you change the pitch
Reverse.
of the?
You mean
Yeah,
reverse.
can you reverse it?
Yeah. So you would take. It's like taking this blade, going from here to a negative blade angle. It's called beta.
And that's what I hear. Like when the turboprops land, it sounds like they're reversing the engine. Are they changing the pitch to that?
You're changing the blade. Normally we don't go to reverse because it adds too much vibration, but you can.
Because I can hear it when they touch down. Like,
Yeah, but sometimes just going to idle, going to a very flat blade angle causes the plane to really it's like putting a big trash can lid out in the airflow, right? Flat blade angle. When you go to negative blade angle, now you're forcing air that's coming this way and trying to start pushing it forward. It's a negative blade angle. It adds a lot of vibration through the airframe, and traditionally we don't usually use negative. We don't go to the beta.
okay,
We
so
just go to flat.
yeah, because it's usually like that continental connection, so they're not going to negative. That I hear doing.
Maybe like on the Saab, I rarely ever went to negative.
Oh,
Rarely ever, just because going to ground idle was good enough.
they probably don't need that much runway to stop anyway.
And plus, if you're an ice nest, if you kick all that stuff up and then you can't see it. Okay? Is that making a little, helping you a little? Sure?
Yeah.
Alright, last thing we're just talking about is the mixture. Let's go over here one more time. There's more air pressure, the air is more dense. So remember, what is this mixture control doing?
The airflow mixture and everything.
Strictly just the fuel. Strictly just the fuel. So going all the way aft, cuts off the fuel flow with that little pump plunger, pops in place, no more fuel can go to the intake of the engine, right? If it's a carbureted system, this little plunge in the carburetor shuts off the fuel. Alright, so for start, put that all the way forward, that's all the way rich. That's allowing the max amount of fuel. So, there's a fuel-air ratio here we're talking about. Air, fuel. Air, fuel, okay? So on the ground we want this rich. After we start the engine, we'll probably lean this out a little bit, right? Why are we leaning the mixture on the ground? Because we have the throttle back mostly for taxiing. So there's not a lot of airflow going to the engine. So we'll lean this out. So that ratio, we don't want an excessively rich mixture as we're taxiing out to the runway. For what reason? What would be the problem with an excessively rich mixture? What starts to happen? We're not talking about a start. We're talking about just the ratio here. There's more fuel and less air.
Combustion.
No, detonation is going to be the opposite of that. Detonation happens when there's less fuel and more air. Okay. So what?
Combustion.
Is it gonna overheat?
Remember, more fuel cools the engine. Alright,
You
let's
said the
think-
opposite of
Let's think about
detonation?
this. Intake, what's happening? Intake, fuel air gets
Ignition.
drawn in. Compression, squeeze. Then what happens next?
Exhaust? Combustion?
The spark plugs ignite. Power stroke. Now we just burn that fuel air mixture, right? Okay, but we had an excessively rich mixture when we went out there. So when we tried to burn all that fuel, were we able to burn it all?
No.
Not if we had a lot of fuel in there. So now we have excessive amount of unburned fuel. And now what's the next stroke? Exhaust. So we're hoping to get rid of all that, right? But what starts to happen? There's residual fuel. And what's the product? What's the byproduct of that? You see that buildup on the engine. Carbon deposits. So what is that? What is it forming on? Exhaust manifold, the exhaust valve, spark plugs, And so they start to foul. So we can get a buildup, excessive buildup of that carbon deposit if we taxi out mixture rich and this back. For a long taxi out there, you might notice on the run-up, when you do the run-up, what do we do with the run-up? This goes forward, this goes up to what RPM?
1700.
Okay, and then you come over here and you move that key. And what do we do there? We're going what? We're checking each magneto individually. So we're going left mag, right mag. So we go to left mag, we're called ground the right magneto, which means now the current for the right magneto is directed other than to the engine. It's not going to the spark plug anymore. Only the left magneto is. And so what we should see here is a drop in the RPM, correct? How much that drops determines, how the magneto's operating. If the RPM drops a lot and the engine's running rough, we have a problem. Because now we're not getting a smooth running engine. We could have a foul spark plug due to carbon deposit on there. Or it could be simply the magnetos. We don't know exactly what the problem is. So we can try to resolve the situation by cleaning the mixture, right, at that 17, whatever your procedure, what your procedure is for